let's begin with question number 8. Okay, let's move it to a whiteboard, please, and discuss that. So the points, they say the points A, B, C, D have position vectors. Aha. What are position vectors? They're given relative to the point of origin. So that means like A, B, C, means A is the first one, is for the A. This is OA. This will be OB. Second one is B until the comma, OC, and OD. It's a three-dimensional position vectors. Okay. So use a scalar product to show that BA and BC are perpendicular. A scalar product is the dot product. Okay. So what we do is generally, okay, we need to find BA first and BC. Okay, let's try to find BA. Okay, I'll show you. There's a shortcut. Whenever you see like BA based on the position vector, some people write straight away B minus A. But in case, that means same as telling OB minus OA. Aha. Okay, sometimes if you find it hard to think how they got this, so just show this once so that it's easier to remember. So the idea is OA and B are something like this, A and B. So these two are generally given. OA is position vector. So OB, let's say, is B, really here, position vector. This way is A. So this way is minus A. Okay, so minus A is two ways. This one is OA. A, this is minus A in reverse. So what I'm trying to say is, okay, let's say I just change this. Oh, sorry, this I wrote wrongly. Yeah, it's always the letter from the right minus the left. Okay, so I just move this. Sorry. So meaning that the letter from the right, A again, A minus B. So this will be OA minus OB. Okay, how do we know that? Even if you didn't memorize that, so I didn't memorize it, as you saw. That's what I was trying to show from here. So BA, like that, walking from B to A is same as walking from B to O and then O to A. So O to A is A. B to O is the negative of the position vector. Position vector always from direction is O onward. So B is the other way around. Means in other words, for comparison, this would have been B. See the arrow different? That's all, negative and positive. So adding that two, so A minus B, A plus minus B, getting the same as walking from B to A. So remembering this, a shortcut sometimes is useful, especially at this level. So this is just taking OA, that means the 3I plus 2K minus the OB bracket. Just don't forget the bracket. So 2I minus 2J plus 5K. 2I minus 2J plus 5K. So 3I plus 2K. So I simplify this, open the bracket up, regroup. So minus 2I, I first, then minus minus plus 2J. So we've got plus 2K minus 5K. Okay, please take note of the multiplication like that. So when you multiply it out, it becomes 3 minus 2 is I. This one is plus 2J. 2 minus 5 is negative 3K. Okay, this is the BA vector. Okay, let's do the same please for the BC, the vector, because we want BA and BC. So in this case, it will be C from the right minus B. So we know the shortcut already, which is the equivalent to OC, position vector of C, and minus OB, so standard, what do we say, terms. Okay, let's look at OC please. OC from the list after. Now here, remembering where, is 2J plus K. Let's copy 2J plus K. Sorry, 7K. I see, almost missed that. 2J plus 7K minus bracket OB. OB is 2I, 2J plus 5K. Okay, 2I minus 2J plus 5K. So when you multiply everything out, meaning that this negative sign multiplies, and rewrite it in terms of the order. The I first, so make negative 2I. Then the J plus 2J minus minus another plus 2J here. And then how about the K? Plus 7K minus 5K. Okay, let's simplify this part first, please. This is minus 2I, 2J, 2J is 4J. 7 minus 5 is 2K. So that's the meaning of BA and BC being perpendicular. That means now we need to check that part lah. So finding BA and BC first. So scalar product. Scalar product for two vectors will be, what would it be? So in the IJK form, just multiply. That means, it means I want to show a general one, thinking what color to use. Okay, let's say X equals to AI plus BJ plus CK. So Y equals to DI plus EJ plus DEF. Okay, like that. So the scalar product or dot product, it's called scalar or dot product because the output is not a vector, it's a scalar dot product. Okay, there are two ways of calculating. Sometimes they equate the two. Not in this case, but we're using the IJ form, IJK. So IJK means dot like that, dot product. The other one is a cross product. It's different. Okay, both got its own use. So basically what it means is you take the A, the I and I as just an AD, BE plus CF. Simple as that. Okay, we're tying up these two from these two. Okay, so the idea is this is also in another way, if you calculate it with the modulus of X times with the modulus dot times modulus of Y, then cos the angle between them. It's the general idea of the dot product of two vectors. So if you notice that there's the IJK form and the dot product of two vectors are the what we say, they're not the IJK form, the modulus form. Okay, so when they equate each other, so the cos theta, if it's like 90 degrees means it's zero, you see. Such a thing. So that's why it becomes zero. So that's the trick. Or if that means cos 90 is 0, 1. So perpendicular is a special case. Now you can see why. So if you want to show that this one is the angle between them, theta is the angle between the two vectors. So the two vectors are 90 degrees like that. Then cos theta is cos 90. Cos 90 is 0. So that means this must be proven as 0. So that's the reason. So I'm giving a theory behind it. So that is why we're going to calculate now the dot product for these two vectors to see whether it is 0 or not. So BA dot BC, the two vectors they're talking about, they want to show is perpendicular. So what we do is, so let's take the numbers accordingly. You all can see here. So I just show it with a visually and comparing the numbers in this box, the numbers in this box in that order. So coefficient of I, 1 and -2. Second one from the top one, 2 there before the J, this is 4. Then plus -3 there in front of the K, here down here is 2. It's as simple as that, just to simplify this. Plus 8 minus 6. So easy to see that it's becoming -8 plus 8 or 0. So hence the two vectors are perpendicular. QED. Okay, let's do the second part now. Okay, they say show that. Sorry, I'll just clear this out. Just like now, BC. The BC part we can use down here. So what I'm going to do is I'm going to take the screen grab for that part. BC and AD are parallel. Okay, so the BC and AD are parallel. Please take note the BC already counted. So that we need to see that to cut short the working. I'm going to recalculate something that already this one. So ta-da! So let's move this here. This is BC from the earlier part, as you just saw. So this is BC. Okay, now how about AD? So we need to do a little bit of calculation for the AD. Let's do that first. So AD means I just need the vector OA here and OD at the corner here. So we just saw those tricks just now. It can be written as D minus A or OD minus OA. So let's take a bit of difference and calculate all this first. So OD is minus 2I plus 10J plus 7K. Okay, so minus bracket OA. Okay, minus 2I plus 10J plus 7K minus OA. 3I plus 2K. 3I plus 2K. Let's simplify plus. minus 2i minus 3i plus 10j, and then this one is 7k. We multiply out minus 2k. Please take note the signs I'm assigning according to the expansion of bracket like this and rewriting the order. So this becomes, let's calculate it, minus 5i. Okay, minus 5i plus 10j. 7 minus 2 is 5k. There we go. This is 80. This is 80, so the vector 80 is here. And that is the vector BC. So we have these two. I just put in the same box so they're easy to see. So show that these two are parallel, let's say. Okay. The one is to show that vector AB and BC, these two are parallel. Okay, at first glance, it may not seem parallel. Okay, it's a very nice question. So I'm just going to write like this, and then they say find the ratio of the length BC to AD. Okay, this one we can do together. That means let me write it like this. AD, looking at AD looks like we've got a bigger numbers there, over BC. Just take a ratio of the two vectors, just like as it means, ratio. Let's just write it. See, parallel means they have to have a common, like everything must cancel out, and only a constant must be there. That's the vector way of proving parallel. Okay, so at first glance, doesn't look like anything common, like the thing and all that. Actually, the reason why is because both of them are having a factor in common. I mean, sorry, both of them can be factorized. So what I mean by that is, please take out, let's say, the factor -2. Okay, now you take -2. So let's just take a 2 out. Easier from the numerator, because all are even numbers. In the denominator, if you look at the 3 coefficients, you see all are multiples of 5. So let's factorize 5 out. Okay, and then let's take a closer look at it. 2 times -i. -i, 2 times plus 2. 2 times 2 is 4j. This one is plus k. Okay, so down here, notice 5 times 1, -1, 5 times 2, and also times k. So this is a remarkable step because you can easily see that this thing is exactly the same for the ijk or the vector component part, isn't it? Ta-da! So why am I rewriting that or recopying? Because when I do cut, I don't like to destroy the original. So we maintain the original, then we do the cut on the newly formed one. So let's do that, please. So this is just identical, we cut. So the ratio is 2 to 5. So 2 things we have done. One is we found the ratio of, they want BC to AD. There's one small trick here. So we write it upside down because they want here to specify the order. This is actually AD to BC. Vector ratio and the length ratio are the same. So reverse it or invert it. So BC to AD, I can just drop the vector also, will be 5 over 2. So the answer in the ratio is 5 to 2. Okay, that's one answer. And the reason vector, I'll just give one last comment here. It doesn't matter in which order you write this, as long as you write it like AD equals to 2 over 5 BC. So general idea is if AD can be written as K times BC, a constant K, where K is a constant. Okay, not talking about the vector K, please take it as a constant. Then AD and BC are parallel as a line and also as a vector. Okay, line segment or vector, doesn't matter. So vector AD will be parallel to BC. So that's how we do this question. Thank you.